Hello everyone. This video explains the EMG data that is acquired during running from 135 healthy volunteers. This video aims to provide more insight on this data set, which may be helpful for researchers in the field of sports science, medicine, engineering, movement neuroscience, or even students training in any of these fields. Let's start this video with knowing more about gait cycle, EMG data, and how to record them. Gait cycle is an action made by individuals during walking. It can be divided into two subphases, stance and swing. We will learn more about these actions while exploring its data. EMG is electromyographic signal produced by skeletal muscle in response to nerve stimulations. Analyzing this signal can help us to know more about the force that is produced by that muscle. As we can see over here, this represents the EMG signal recorded with a surface electrode placed on the skin, and below is the force produced by the muscle to trigger the action. This recording of EMG can be done with either a surface electrode or a needle electrode. Surface electrode is placed on the muscle where we want the recording to happen. Now we will look into who are involved in the data collection and how the data is collected. This experiment involved 135 individuals with these weight, body mass and age, of which there were 57 females and 78 males. The participants ran on the treadmill with an average speed of 2.65 meters per second. Before starting the run, they included a warm-up procedure for 5 to 10 minutes. Some participants ran at a predefined speed, while the others were asked to find a comfortable speed for themselves. The muscle activity of 13 ipsilateral muscles, as highlighted here from the right lower limb, was recorded with a frequency of 1000 Hz. 2 trials of 30 seconds for each participant was recorded. Now we will look into the details about the dataset provided, which will include the metadata, gait cycle data, EMG data, and muscle synergy data. Metadata gives background information about the dataset. Here 8 different information is provided. First column is the code of participant, followed by sex, speed of recording, type at which the participants ran, which is either preferred or fixed, age, height, body mass, and strike index. This data can be found in the participants underscore data.dat file, which can be downloaded from the dataset.jar file provided on the site. Gait cycle is divided into stance and swing phase, which includes the following subphases, dividing the action of walking into a circular signal motion. In gait cycle, we have foot strike on the ground, which is identified by analyzing foot pressure distribution. This data is normalized to 200 points with 100 points to stance and swing phase each, which will help us to make the result independent from absolute duration of gait events. These data contains rows of multiple recordings done for each individual participant. The columns provide us information on what data is provided in each file. Naming of the gait cycle parameter is cycle underscore times underscore participant code underscore number of reading.dat. In this we have 30 rows, of which 2 columns for each individual. First column is the touchdown time in seconds, and the second column is the duration of each stance phase in seconds. There are 2 types of data recording provided. First is the .dat and the other is .rdata. These data are provided in a specific folder in gait cycle parameters. The EMG data is recorded from 13 epilateral muscles. There are three types of data provided for EMG. A is the raw EMG without filter. B is passing raw EMG data through a high-pass filter with cutoff frequency of 50 Hz. C is after passing high-pass filter data through low-pass filter with a cutoff frequency of 20 Hz. This image shows us how the recording for different muscles to time looks like, which is provided in the dataset file. The abbreviation for each of these muscles can be referred here. Each participant has 30,000 data in total. First column with time in seconds, and the rest 13 column is for each of the muscles. The headers have muscle names abbreviation helping us in identifying them. We have two types of files provided for each participant. First is raw underscore EMG underscore participant code for raw EMG data, and the second is FILT underscore EMG underscore participant code for filtered EMG data. This data can be found under the EMG folder with specific filters and raw data collection. Muscle synergy is a group of muscles recruited together to perform specific action. These group of muscles should have similar activation balance to be triggered together. It helps in analyzing muscle activities and to identify contribution of each muscle for producing certain movements. Muscle synergy is extracted from the filtered and normalized EMG data. For extraction, classical NMF algorithm non-negative matrix factorization is used. It is the most common method for reducing a high-dimensional electromyographic input into a small number of synergies. For NMF calculation, we can use this formula here, where V being the original data set, which can be reconstructed from H, motor primitive, which is a time-independent coefficient of factorization, and W, motor modules, which is a time-invariant module with muscle weightings. In this figure, we have motor modules, which are time-invariant coefficient, and the motor primitives, which describes the evolution over time of basic activation patterns and represent them with time-dependent curves. We have four muscle synergies represented here, highlighting the important gateways. The first synergy is referred to the body weight acceptance phase, with a major involvement of knee extensors and glutes. The second synergy is described as the propulsion phase, where the plantar flexors mainly contribute. The third synergy is the early swing phase, showing the involvement of foot dorsiflexors. The fourth and last synergy is the late swing and the landing preparation. This highlights the relevant influence of knee flexors and foot dorsiflexors. There are 60,000 rows of data in two different files. First is SYNS underscore H underscore participant code for motor primitive data, followed by SYNS underscore W underscore participant code for motor module data, which can be found under the muscle synergy folder. More about the generation of muscle synergy from EMG data using NMF can be found under the R code folder describing its implementation. For the last part, we have use case of the dataset provided and its limitations. Sometimes due to experimental or design constraints, 5 to 20 individuals are recruited. This dataset provides increased representation of data with 135 volunteers. The EMG and the muscle synergies can help us in making more advanced musculoskeletal models and control active exoskeletons or robots which can substitute human movement. This data can be used for broadening the representation of human motor control. This can also be helpful to advance research in existing muscle synergies extraction. It can also help train students in different fields like sports science, medicine, engineering, mathematics, or so forth. This dataset is for young and healthy individuals running only on treadmills, so it cannot be used in different environmental setups. The speed of the participants were not same even though the average speed was close to the participants' preference. This also only covers data from the right lower limb. This brings us towards the end of this video. Here are some of the references which you can further explore. And this also includes the reference to the paper that I have referenced. Feel free to explore that as well. I hope you find this video helpful. Thank you for listening.